All right, guys, I'm putting together a quick video on how to convert coordinates, rectangular to polar and polar to rectangular. A lot of it has to do with drawing a picture and just kind of analyzing it as a triangle if possible, or if it's on an axis, pretty straightforward. So we've got this first example of converting 6 comma pi over 2 to rectangular. And 6 comma pi over 2, if I thought about that as a picture, that's an angle of pi over 2 rotated counterclockwise and jumping forward 6 units, which would be that point right there. Well, if I thought about that as an xy plane, then I went 0 units on the x and 6 units on the y, and it's as simple as that. Second example here, not as easy, but we could still kind of work through it by drawing a picture. If we think about the picture rotating 7 pi over 6, that's going to be an angle that rotates into the third quadrant. But again, facing in the third quadrant, still jumping backwards 8 units though. So that's actually going to be this point over here. What I'm going to do is I'm going to make a triangle out of this. As a non-calculator type of question, you would answer this based off of our special right triangles. So 7 pi over 6 is a reference angle of 30 degrees. So in a 30, 60, 90 triangle, it's in a 1 to 2 to radical 3 ratio. So it's in a 4 to 8 to 4 radical 3 ratio. So my coordinates would be 4 radical 3 for the x, because I went right 4 radical 3, and 4 for the y, because I went up 4. So let's try one that's not in the first quadrant just to see what happens to encounter that. So let's see this. I'll jump to example F here. If we rotate 7 pi over 4, so 1, 3, 5, 7 pi over 4 is facing in the fourth quadrant, but jump backwards 1 unit. That's this point here. We've got a 45, 45, 90 triangle. So that's in a 1 to 1 to radical 2 ratio. So then that would mean that this is 1 over radical 2 or radical 2 over 2. And this would be negative radical 2 over 2 because of the fact that we moved to the left and up to get to that point. So the x coordinate would be negative radical 2 over 2, and the y coordinate would be positive radical 2 over 2. On the next page, I've got actually a couple of these filled in, but I'm going to erase them so you can see what I'm going to do here. Now I'm going the opposite direction, convert from rectangular to polar. So -5, -5. If we plot that as a point, we would go to the left 5 and down 5. Still building our special right triangle. So this distance is r, 5 radical 2. And that's just off of the ratio of the 45, 45, 90 triangle. So 5 radical 2 is our r value. And then theta, here's the unique thing about polar coordinates. There's more than one answer. Did I rotate counterclockwise? If so, then my answer would be 5 radical 2 comma 135 pi over 4. But I also could have rotated clockwise. And I could have had an answer rotating this way. And I could say 5 radical 2 with a negative rotation of 3 pi. And I'm still not getting just those two answers. I could have done that. Let's say I decided to face the first quadrant, but jump backwards. Well, then my r value would be the same magnitude, but negative. And theta would be pi over 4. And I guess if you really wanted to, you could also rotate around negative 7 pi over 4. And the list goes on, right? I could go around 2 pi times if I wanted to. So this kind of gives us a list of coordinates, or sorry, values that we could come up with for any relationship between Cartesian and polar. If I'm always building a triangle, the x-coordinate is the horizontal, the y-coordinate is the vertical, and then the r is the hypotenuse. Well, Pythagorean theorem gives us x squared plus y squared equals r squared. SOHCAHTOA trig gives us that tangent is equal to opposite over adjacent, which would be y over x. And therefore, the inverse tangent of y over x would be theta. Again, using SOHCAHTOA trig, I could have that the sine of theta is equal to the opposite over the hypotenuse, giving me y over r. And if I wanted to solve that specifically for r, I'd have y equals r sine theta. And same for cosine. Cosine is the adjacent over hypotenuse. And if I solve that specifically for x, I'd get x equals r cosine theta. I'll use these in the next video, though, to help us answer some conversion of equations. But for now, we'll just leave it at that. Again, my suggestion would be to draw a picture. If it's on an axis, then you could just analyze it by figuring out how many units you went from the pole, from the origin. If not, then you draw a triangle and kind of go from there. All right. Good luck.